See, my last class, I'm talking about this ion selective electrode construction working of glass electrode. Okay. See here, the ion selective electrode means it is the one which selectively responds to a specific ion and develop a potential at the electrode in a mixture is a function of the concentration of that ion in a solution. So in the solution, there may be plenty of ions with a different concentration and a different ions. In that, a membrane is present in the ion selective electrode which responds to a particular ions and develop a potential at the interface. Okay. And the construction part, it consists of a thin-walled glass bulb made up of special type of glass with high electrical conductance, as you see here. So it consists of a thin-walled glass bulb. And this glass bulb possesses a high electrical conductance. Usually silicate glass may be used for this purpose. The glass bulb, which is filled with N by 10 HCl solution, and it is inserted in the middle, and simply silver chloride is inserted in the middle of the bulb, which is act as an internal reference electrode, as well as it may be used for external electrical contact, or that is connected to a outer part connected to a platinum wire that is in turn connected for an external electrical contact. And this electrode is dipped in a solution containing H plus ions of different concentration. Then of different concentration. Yeah. Then electrode can be represented this way. It contains internal reference electrode, silver chloride electrode, that we will write first. That is AgCl. This electrode here, it is present here in the middle. Okay. That is this electrode we simply represent this way: Ag bar, AgCl bar, Cl minus, that electrode. In turn, this electrode is in contact with this ions N by 10 HCl, and in turn it contact with the glass. That is we represent here Ag bar, AgCl bar, Cl minus bar, N by 10 HCl bar glass. When it is dipped in a solution, the reference electrode what we used externally, it is in turn connect with external analyte solution with a concentration H plus equal to C1. Here we connect another electrode, and that electrode what we called it as a reference electrode, and this reference electrode contact with the external analyte solution. External analyte solution is contact with the membrane, and the membrane we can observe a difference in the potential. That is the outer potential what we write is E1 and the inner potential is E2, which in turn it contact with the internal standard solution N by 10 HCl. Its concentration is taken as C2. In turn contact with silver chloride electrode. And here, when you dip this electrode in a solution whose pH is to be determined, so as a result, an ion exchange reaction take place. Thereby, it reflects in turn pH of a solution. H plus ion present in the external analyte solution interact with the Na plus ion present in the membrane. An ion exchange reaction take place, and Na plus ion move into the solution, and H plus ion comes to a membrane. So, due to difference in a H plus ion concentration inside and outside the glass bulb, that give rise to a boundary potential across the membrane because of gel layer development. So, that boundary potential usually we express as Eb is equal to E1 minus E2, that is equal to 2.303 RT by NF log C1 by C2, where C1 is the concentration of H plus ion of the solution into which the glass membrane is dipped, and C2 is the H plus ion of the acid solution inside the glass bulb. That is what we called it as a standard solution. Here the C2 is a constant and N is equal to 1 because we use H plus ions. So Eb becomes equal to constant plus 2.303 RT by F log C1. At 298 Kelvin, the equation becomes Eb equal to constant plus 0.0592 log C1, where constant can be represented as L, that is equal to minus 0.0592 log C2. So we can write Eb is equal to L plus 0.0592 log C1. Okay, Eb equal to L minus 0.0592 pH, where pH equal to negative logarithmic to the base 10 of concentration of H plus. Here the negative logarithmic to the base 10 of concentration of C. That is concentration of C1 is nothing but pH. Sorry, nothing but H plus ion concentration. So we can write log C1 in place of log C1 we can write minus pH. So that means the boundary potential depends on concentration of H plus ion. So this is a portion of glass electrode potential. So the glass electrode potential is the combined form of the three component. When it is immersed in an analyte solution, acidic solution, then the potential of the glass electrode Eg is given by Eb plus E reference plus E asymmetry, where Eb is the boundary potential, E reference is the reference electrode potential, E asymmetry is the asymmetry potential. See, but what is this E asymmetry? E asymmetry is when you use the same concentrated solution inside and outside the glass bulb, you can observe a potential. Okay, even though theoretically EB should be 0 when C1 equal to C2. However, a small additional potential is observed, and that additional potential, it is in particularly glass electrode we observed. So that potential, what we called it as asymmetric potential, that is mainly due to the presence of that gel layer creates a potential E1 C1 equal to C2. That potential called it as asymmetric potential. So that Eg equal to L minus 0.0592 pH plus E reference plus E asymmetry. So the standard glass electrode potential is the sum of all constant terms like L plus E reference plus E asymmetry. So that we can write the glass electrode potential Eg equal to E naught G minus 0.0592 pH. Okay. So in this way we can arrive the glass electrode potential. Okay. Then advantage of glass electrode is can be used in oxidizing and reducing environment. Here electrode does not get poisoned. By using special glass electrode, pH 1 to 14 can easily be measured. The main limitation of this electrode is special glass electrode can measure up to pH 12. Above 12 pH, cations of the solution affect the glass interface and render the electrode useless. And even in a high or low pH acidic solution, pH less than 1, the salt effect due to anions are observed. And because of high resistance of glass, it is necessary to use special electronic potentiometer. We have to take care of these three component or limitations. Okay, determination of pH using glass electrode. Okay, so here the main function of glass electrode is to determine the pH of a solution, given solution. So for that, we may use a pH meter directly, or by using potentiometer, we can able to determine the pH of a glass electrode. Okay, the determination of pH using glass electrode. To determine the pH of a solution using glass electrode, you have to construct a cell. Okay, in order to determine a pH of a solution, the glass electrode is dipped in an analyte solution whose pH is to be determined. Here, I just dipped a glass electrode in an analyte solution whose pH is to be determined. Solution of unknown pH. That is what we called it as an analyte solution. Then this electrode is coupled with a reference electrode such as calomel electrode. It is coupled with, because the calomel electrode potential is known. Their electrode potential is known. Okay, known potential. So by using this, I can construct a cell and the two electrodes I connected by means of a voltmeter. Okay. In order to determine pH of a solution, the pH electrode, that is glass electrode, is coupled with the calomel electrode, and the two electrodes are dipped in a solution whose electrolyte concentration is to be determined. Then I can represent the cell. Okay, how can we represent the cell? The two electrode is coupled together. That becomes the representation of the cell. Okay, representation of cell. So I can represent. So mercury, this first. So what is the electrode present? Representation here. The calomel electrode, by sign convention, the calomel electrode is taken in the left side and the glass electrode right side. Okay. So taken as anode by convention. So then only you can get the positive EMF. So that's why the calomel electrode, I put it in the left side. So the left side electrode should be read first. Hg bar Hg2 Cl2 bar Cl minus. Okay. This in turn contact with a solution whose pH is to be determined. Yeah. And this solution is in turn contact with the glass bulb. In turn, the glass bulb contains 0.1 m HCl, internal standard solution, and it in turn contact with the electrode, that is Ag plus bar Ag. This is a representation of cell. Up to this much, this is a anode representation, and this is a cathode representation. Okay, this way we can represent this cell. We have to construct a cell. Okay, like this. Anode and cathode, the analyte solution. So first we write the anode part. Usually while representing anode, first we write, that is a calomel. Calomel electrode representation is Hg bar Hg2Cl2, Hg bar Hg2Cl2 bar Cl minus, and this contact with this analyte solution whose pH is to be determined. Then it in turn contact with the glass bulb, and that glass bulb possess HCl solution of standard 0.1 HCl, 1 NHCl, and in turn it contact with Ag plus Ag bar electrode. Because I'm not mentioned again Cl minus, because it is already will take HCl, so in turn it is same. Okay, this way we will construct the cell. Then we want to detect the potential of this cell. So by using this potential, we can able to calculate the pH of a solution. So E cell equal to, I'm taking here E cell, not E naught cell, because no unknown concentrated solution is taken. Unknown solution, unknown pH solution is taken, and we are not known whether it is 1 molar or other than 1 molar. So simply I'll take E cell. E cell equal to E cathode minus E anode. The cathode electrode is a glass electrode. So that is E glass electrode minus E standard calomel electrode. Okay. See here, the calomel electrode is taken as anode by convention. Okay. Just by convention, I'll take this one as a anode. Then we know the glass electrode. How we represent the glass electrode potential? Okay, E cell, now it is equal to, glass electrode is E naught G. You just arrived this one. E naught G minus 0.0592, or in some book it is 0.0591 pH. Okay, minus, okay, minus E standard calomel electrode. Okay, so that is equal to, our intention is to arrive the pH of a solution. Our intention is to arrive the pH of a solution. I'll take this terms left side. Okay, minus 0.0, I'll keep as it is 592 pH, that is equal to E cell, okay, minus E naught G, because it comes to left side, E naught G plus E standard calomel electrode. Okay, what I want to arrive pH. pH equal to, now it is equal to, okay, I have to change the sign here, negative sign, negative comes to this side, so becomes these terms become positive. So that's why I'll write first E naught G, okay, E naught G minus E naught G minus, okay, E standard calomel electrode minus E cell by 0.0592. Okay, this in this way we can derive, or we can arrive the cell. E cell, pH equal to E naught G minus E standard calomel electrode minus E cell by 0.0592. So pH of any solution can be determined by potentiometrically. Okay, not by this one direct pH meter. By potentiometer we can able to find the pH of a solution. Okay.